Hi everyone, welcome. Today we'll be building this simulation. I think they're usually called Boids, but I think it's pretty cool. As you can see, there's a bunch of circles, and they have an algorithm that makes them move towards this black target. The algorithm that makes them do that has a bit of a randomness in it. It's pretty cool. And as they grow, if whichever one reaches the target first grows in size a certain amount, and as they grow and reach different sizes, they actually change colors. Let me start it from the beginning. So you can see this is how it begins. Slowly it evolves and changes. I think it's pretty fun. Let me actually play it sped up so you can see how it kind of evolves. And once, if a circle grows too large, then it just resets back to its original initial size, that is. So this is sped up like about 10 times. We'll be using chatgpt along with OpenAI's Playground, and of course Visual Studio Code and GitHub Copilot to help us do that. And most of the coding is going to be done by AI. When I was doing this over the course of about a day or two, about 95% of the code was done actually by AI, so it's very possible. Here is the code. It's about 200 lines, as you can see. It's pretty cool. So we'll start with, I've tried both ChatGPT and OpenAI's Playground. ChatGPT is very cool and you can interact with it sometimes more usefully than OpenAI's Playground. But the fact is that OpenAI's Playground is just is so much faster when it comes to generation. And this took quite a bit of trial and error, and I'm sure it'll happen this time around too. So we'll most likely start with the Playground using Codex DaVinci 002, and then we'll see where it goes. So to be able to do this, I will create a specification list, like what do we want, what are the general principles of what we're trying to achieve. For example, there's going to be a screen. Well, we're going to be using Pygame, right? And there are going to be circles which move around randomly, but then they need to have an algorithm that makes them move towards the target. So the circle, we're going to have a circle class and a target class, and each time the circle reaches the target, then something happens, right? For example, it grows in size. So we got to account for all those things. Well, we'll start simply and build from there. Also, the target changes its position each time. So let me create a spec sheet, and then I'll be right back. Okay, so let's start with something like this. Pygame canvas simulation. Let's just start with that. Window is going to be 1200 by 800. I said create a circle class. I said create 20 circles, size 3, speed 5, blue color. And then I said create a target class. I should move this down. I'm doing it like this so that maybe if we fail at some point in time, we can add more to it and start from scratch and try all kinds of different things. So size 10, stationary, black color, which is going to be the target. So what we're going to do is just copy this, right? Bring it into Playground, and we're going to make a doc string, just like that. Select Python, and then let's give it about 800 tokens, a little bit of temperature, so it can be a bit variable. And then I'm going to start with import, and let's see what it comes up with. See how fast it is if you've used ChatGPT. So what I was saying was this is so much faster currently from ChatGPT. So sometimes it creates game logic go here, and we don't want that. We want the entire logic written. So Let's see what we can get. Yeah, it's doing a lot of stuff. We don't want that. We just want something simple. So let me run it a few times, and once I find something useful, I'll start the video again. Okay, so after trying a few times, so I got something like this. I copied and pasted it into VS Code, and when I play it, I got something like this, which is kind of crazy. I don't know if you can see it, but they start slow and then start moving kind of crazy all over the place. I'm not even sure if they're bouncing off of the edges of the screen. And yes, they are. We can see it right here. Let me actually zoom in here a little bit. There we go. So this is a good start. So it created a circle class, target class. These are all fine and well. It's assigning it into a list, which is good, and then just doing this. So let's try to implement then well, first let's fix the speed. The speed is speed, so let's see. Speed is 5. So why does it seem, what if we did speed 2? They're still moving very fast. Okay, I think I think the problem is that it's rendering the screen with pygame.display.update, and in the beginning of the video, the one that I showed you was using clock.tick, and this actually allows you to set the frames per second. I think this is just trying to run as fast as possible, and depending on the availability of the CPU, it speeds up or slows down. This, somebody please correct me if I'm wrong, but I believe this is what's happening. So instead, what I'm going to do here is let's add Pygame. So I'm going to say use display.flip, use clock.tick as a into our spec, so because this will allow us to control the frames per second. Also, let's add here, well, it already had done that, but circles bounce from the edges of the screen, just in case, since we're going to try it again. So let's get this. We're going to repeat the same process. Put this here. Is it docstring? We'll start by saying import, and we'll see where this goes. Okay, we got something in the first try, which actually implemented, oh, it's this one. Okay, it did implement the clock.tick. Let's put some space here. Let me look into these. Pygame is not defined. We can actually, it didn't, maybe we can let import random, yes, do import math, please. Initialize Pygame, okay. Let's just run it, see if it works. Okay, it's still too fast. Okay, I think I figured out. So when we run it, they move. I just reduced the speed to 5. Clock tick to, well, let's put this back to 60. So this works well, except they're all moving in the same direction, as you can see. We are going to have to change that, and also they bounce off in a very predictable way too. So the reason, first of all, they're moving in the same direction is because whatever position they find themselves in, it's just both the x and y values are added to speed, and the game screen starts from the top left from being 0, so they all move towards the same, so towards the right and the bottom, right? Essentially. So what we want to do is randomly choose between positive and negative speed. So this should do it. Space. So Copilot is helping us here. Now hopefully they should be moving in random directions, but they don't seem to be going too far because they're changing directions every iteration of the while running loop, because every time they check and get a random movement. So what we're going to do is then come back to our spec sheet and say we'll do 2 and 3. We're going to say circles are moving in random directions, and then we'll again repeat the same process. Paste it here and run it. Okay, we got another one, and I actually tested it. It fixed the directionality issue, but when they hit the edges of the screen, they just kind of get stuck there. So there's a problem with this bounce formula. So I'm just going to copy it, and this time, oh, my mistake. This time let's actually try ChatGPT. Let's give this and say modify this code so that what do we say? So that the elements bounce from the edges. Oh, maybe we need to refresh it real quick. Modify this code so that the elements bounce from the edges. Okay, hopefully this will work. Okay, actually ChatGPT got it right in the first try. So it modified the bounce. I copied it, pasted it instead of the old bounce, and now if we run it, we get a nice little animation going, simulation. So far so good. So what we want to do next is define the algorithm which is going to make them move towards the target. Now I don't want them explicitly moving towards the target, but I kind of want their way by kind of like trial and error. So what I thought of then doing was, so we'll get them move, and then let's see. That's right. So what I'm thinking of doing is, actually let me run the original one real quick. So what's happening here is, let me slow this down real quick. Slow it down. So what's happening here is that they're all moving in different directions, and they're checking every second or 2 seconds, every so often, if they're moving towards the target or not. And if they are moving towards the target, they keep their current trajectory. If they are not moving towards the target, then they just choose a random direction. So not towards the target, but just a random direction. But this overall, when they're running, essentially makes them run towards the target, or in the long run, that is, by trial and error. So we're going to try to implement something like that. So to be able to do that, I'm going to try at least to get this move method, and let's just give it to ChatGPT. We're going to give this, okay, and let's just give that real quick, and then I'm going to take the target and give that as well. Once it's done, maybe I should have, you know what, I'm going to actually give both the target class and the entire circle class, and then I will just here say I want circles should move randomly, and every second check to see if they are moving towards the target. If they are not moving towards the target, then they start moving in a new random direction. So let's see. Okay, it understood it. To make the circles move randomly, and then check if they're moving towards the target every second. You can modify the move function. Let's see what it does. Okay, it's still continuing to write, but I think this is what we need. As you can see, check if the circle is moving towards the target. So it is moving randomly. And then checking to see if it's moving the target. If the circle is not moving towards the target, then it chooses a random direction. All right. So let's get this class and replace it. If I can, that is. Let's just copy the whole thing. We'll erase the last bit. So we're only going to be replacing the class. Let's do that. Delete this part. We don't need this. So let's run it. Let's see what happens. Move missing one required. Positional argument target. Okay, I think the problem is here because now that the new move method takes in an argument called target, but in our main game loop we're not passing it. So if we just say target, this should do it. Okay, pretty cool, but this is not exactly what I was looking for. Let's see. Okay, I think the problem is, as you see here, in the move method, it's checking if it's moving towards the target right away. So every time the game is trying to draw itself, it's checking, so it's giving and changing directions at all times. So it's making this jittery movement. I'm pretty sure I have a, let's just see for fun if they're actually slowly approaching the target with this. Not really, maybe, not really. Okay, so what we need to do, I think, is get this move and split it into two methods. One for just moving and one for detecting the distance. So let's try text DaVinci this time. We'll say split this method into two methods. Okay, so what happened is that the text DaVinci just wasn't doing it. I tried 4 or 5 times. So I just switched to code DaVinci, did the exact same thing. I just put them as doc strings, exactly modified methods. And these work, kind of. I pasted them here, as you can see. And I have commented out the check distance for now. We'll also have to remove the target from the move method, because only the check distance is accepting the target now. So anyway, without checking the distance now, we got what we want as far as the movement of the particles, the circles. But if we enable the check distance, again we get the jitteriness, because what's happening is it's trying to check distance every time, and it's really not keeping track of if it's moving towards the target, because we don't want it to change if it's moving towards the target. To be able to achieve that, we need to actually employ two variables, well, in this case attributes, self.previous distance and self.current distance. They'll both be 0, and then I need to check distance. Let's see what GitHub Copilot comes up with using previous and current distance. Yeah, so this should do it. See, so because what we do is we're going to get a current distance, but before we do that, we set the previous distance to our current distance, and then we calculate the current distance, and then we do, yeah, if the current distance is larger than previous distance, then change direction, because if our current distance is smaller than previous distance, that means we have moved towards the target. Our distance to target has been lessened. It's smaller now. So I hope you got the logic of this, but if you run it, this should work, hopefully. Yeah, okay, so we get the same behavior. So let's do it again. So let's slow it down real quick to 30. Now if you run it, as you can see, they're moving in random directions, and every so often checking and changing to a random direction, and eventually they'll stop changing direction because they'll be moving towards the direction, and they'll do more switching of the direction as they get closer. Eventually they converge on the target, and this is what we wanted. So next we need to, let's see what we need to do. We need to change the target's position each time at one of the circles collide with the target, right? So yeah, so we need to have the target changing its location each time. Whenever the first particle actually is colliding with the target. So to do that, let's try again. Let's try the code DaVinci. We are going to give the entire code to it as a doc string, and we will say when a circle collides with target is drawn in a new random location. A little bit of temperature, let's give it about 800, and we'll start with import and see what Code DaVinci can do for us. Okay, this was our first try. It actually written it, and I have actually copied it and pasted it just to test it out, and it works, as you can see. And particles actually keep changing directions to keep track of it. This was it's pretty good for a first try. Okay, now let's get this again and say, again, we'll do the same thing. Give it as a doc string and say that we're going to say each time whenever the particle collapses with the target, then it grows in size a certain amount. So I'm going to say when a circle collides with the target, its size is increased by 1.5. Let's begin with import, and let's see what Copilot comes up with. Let's see if it's going to collision. Yeah, so check collision. Okay, Okay, it's going to return true or false. Continue. Not sure if it's applying that. Okay, it's done. And actually, right here, let me zoom in. So it said check collision. If it had collided, circle size 1.5 times 1.5. So this should work, in my opinion, but you never know. Let's copy this, paste it, run it. Fingers crossed. Okay. Yep. I don't know if it's visible. We can just do this 3 times and increase this to 60 frames per second. Okay, great. We got it. Perfect. All right, we're almost there. Let's deal with the color next. For that, maybe we can, in the beginning, we can define some colors, like define colors. Okay, this is Copilot helping us. Let's get some colors. Light gray, light blue. This should be good. All right. So what we want then, so the circle already has a color property. So all we have to do is, I believe, we need to keep a counter while running. We need to keep a counter. We can just code it ourselves, but we need to initiate a timer in the beginning. Let's code this ourselves. Timer equals 0, and within the game loop, let's say at the end of it, timer plus equals 1, and for circle and circles, like let's check right here, say check for timer for 2000, let's say. Yeah, here we go. We'll do blue. Here we go. So, so this goes pretty quick, right? So 2000. This is not actually. I'm sorry, but we could do this too. So we can actually. This is not what we wanted to do, but let's say 500. So every so often they'll be like changing color. This is actually. Does it work? Oh, it's already blue. Let's say red. Yeah, see, it ran pretty quickly, but if we do 3000, should happen. It's still going too fast. Let's say 7000. 70,000? Maybe I'm missing something here. Let me take a look. Okay, so I just had to move the timer to inside of the for loop, so I just did it 3000, but look what happens. Only one of them turns red. You see that? And it happens pretty quickly too. The reason is because we go for circle in circles, right? So we're going through each circle. We have about 20 of them, and then it checks if the timer had reached this point, and then it comes to the end of the for loop, and then it adds 1 to it, and then when the timer will only fulfill this position while one of the circles is being observed in this case, and it just happens to be only one. So to fix it, I believe we have to do another loop here for circle and circles. Yeah. This is probably not the best way to do it, but let me see. Still missing something. Okay, you know what? I'm going to come back to this. I'm probably missing something super obvious. But anyway, this timer actually we're going to use to shrink the circles over time so that they get smaller and smaller. And only when they coincide or collide with the target, then they actually grow in size. In this case, like 3 times. But the color change is going to happen essentially. So let's actually comment this out. Color change is going to happen when they reach a certain size. This is how I implemented it in the original version. Meaning, for example, for circle and circle, so we're going to check if circle dot size, we start with 5, right? If it's bigger than 10, then the circle turns red. Let's see if this works. Maybe 10 is going to take some time. Let's just do 6. So yeah, as you see now, if it grows beyond 6, it turns red. So what we can do is we can just comment this and say change color for multiples of 5. Yeah, we're actually going to not use modulo, but say 10 equals, yeah, let's use modulo, why not? Yeah, so 10, oh, and this blue, let's say red. Well, what colors do we have? Let's make it go blue, then pink, green, yellow, orange, and red. Okay, something like that. Okay, so we go to pink, and okay, elif 15 and we're going to move these to the right, to the left. Alright, let's just go with that. Something like that. Do we have purple? Okay, yeah, it doesn't really matter. And let's just go now. See what happens. Okay, see? Now it's working. So the only thing that is left to do is to implement the shrinking over time. And this video is getting a little longer. Maybe we'll just implement one last thing and then we'll just end it here. Which is to say, if we're just going to reset beyond a certain size, reset the size of the circle. We don't need the timer. If the circle dot size is, let's say, bigger than 400, then circle dot size is going to be 5. So let's see if this works. Let's speed it up. So anytime. Okay, did you see? They just pop and go back. So we have this infinite loop. They keep growing and then they keep popping back to normal. Let's run it at somewhat of a reasonable speed, and then we'll end it. I hope you enjoyed this. Please like and subscribe, leave comments with your suggestions, and have wonderful holidays and Happy New Year to you all. This is pretty cool. Thank you for watching. Just want to show you the timer, how it should work. So you set the time to 0, and then in the while loop you keep track of it. You increase the time by 1 each game loop, and then if it reaches a certain level it just shrinks, and here it's using the i.shrink method, which is right here. Shrinks by a very small amount and grows. Actually, I had also implemented the growing as a method inside of the class. You can do it that way too, but this works. Let's just watch it one last time in super fast speed. There we go. Let's actually do lots of, instead of 200, let's do 100. See what that looks like. Pretty cool. A little slower. 400. Hope you enjoyed it. You know, I mean, 95% of it was coded by AI, assisted by AI. A lot is possible. Hope you'll learn something, and hope you'll build something useful. Take care, and see you next time.